All right, so whenever you take actual notes, like you don't need to write everything word for word, but if you don't know how to paraphrase it, then you're going to write it word for word. So an exponential equation is basically an equation that has a variable as an exponent. So like 2 to the power of x, 5 to the power of x plus 2. So you need to have a letter in the power position. So there are two ways to solve. The first way is you're writing them so that the bases, which is the big number, is the same. So we did that on a homework assignment. It was actually your 2.1 ready about 2 weeks ago. So the part that's in white, that's kind of hard to see, it says if b to the power of x equals b to the power of y, that means the bases are the same, then x equals y. So we talked about that a while ago. If the big number is the same, then the exponents, which are your powers, must also be the same. So that's the first method. That's the easiest way. So I always try to see if I can rewrite them using the same base. And if I cannot, then I take a log on both sides, which is what we did on Friday with that task. So the other part that's in white says if A equals B, then the log of A equals the log of B. We're going to be dealing with answers where you're going to have to round. And so sometimes when you round, when you plug back in, you may not get an exact answer. So one thing that I wanted to go over that I saw last week was that if I tell you to round to the hundredths place, that means 2 spaces after the decimal for something like this. If the last number that you're looking at before you want to cut off is bigger than 5, you should be rounding up. So if I ask you to round to the hundredth place, that's 2 spots, that would be 1.58. So just make sure you know, like the 10th would be the first spot, hundredths, second, thousandth, third. And then if you look on the homework for tonight, it says 10,000th. That's 4 spaces. So just make sure you know where you're rounding to. Okay, but basically it tells you because you're rounding, when you plug back in to check, you may not get the exact answer. So say the answer was 5. You might get 4.99999. Well, that's 5. But if the answer is supposed to be 5 and you get like 2.3, well, that's nowhere near close, and so it's not reasonable. Okay, so that's all that part is about. So just know when you round and you plug back in, you may not get an exact answer. Okay, are we good on that? All right, so I'm going to change the slide. All right, so example 1 is 9 to the power of 8 minus x equals 27 to the power of x minus 3. So it's exponential because the x's are in the exponent or power position. So we have a 9 and a 27. So here is where what Mr. Kim taught you guys last week or the week before, where you factor or prime factorize is going to be important. So what can I factor 9 to? 3 times 3. So if I write that as a power, or using an exponent, that would be 3 to what power? 3 squared. So whenever you rewrite a base, it has to go in parentheses. So that's 3 squared to the 8 minus x. And then what are 2 numbers that multiply to 27? 9 and 3. But we know we can break 9 up into 3 and 3. So that's 3 to what power? 3 to the third, or 3 cubed. So same thing in parentheses. And then you do x minus 3. So the one rule that you absolutely cannot get away without knowing from when we spent all that time on Khan Academy and all that time in class doing those exponent rules, you have to know that a power raised to another power means you're going to multiply. So I'm going to do 2 times 8. And then I'm going to turn around and do 2 times negative x. So what's 2 times 8? 16 minus what? 2x. So I drew the arrows in because most of you are going to forget that it's to both things. So if there are two things in the power position, you have to multiply to both of them. If you don't, you're going to end up with the wrong answer. So for the next one, it's 3 times x, which is 3x minus 9. So do them to both. So now that my bases are the same, right, the big 3's, I can cancel them out. I don't care about them. So then you set 16 minus 2x equal to 3x minus 9. And that's something that we learned how to solve 2 years ago, back in Math 1. Okay, so you get your x's on one side and your numbers on the other. Notice how my equal sign is in every single line. So please make sure you write the equal sign. That way you know where it goes. A lot of you will drop the equal sign, and then you're going to end up putting it in the wrong spot and get a totally different answer. Okay, so I'm going to move my x's to the right. So how do I get rid of minus 2x? We're going to add 2x. So what's 3x plus 2x? 5x. So we get 16 equals 5x minus 9. How do I get rid of minus 9? We're going to add 9 to both sides. What's 16 plus 9? 25. So I have 25 equals 5x. How do I get x by itself? Divide by 5, and that tells me that my answer is x equals 5. So I couldn't squeeze the last step, but that's a one-step equation, and I know you guys know how to solve that. So how do I check my answer? We plug the 5 back in. So I really recommend that you get in the habit of checking your answer. So that way you know before you turn something in, does my answer make sense? And if you have time, like if you're finishing early, like some of you finish like 10 to 15 minutes early, you better check your answer. Because then that could be the difference between an A and a B, or a B and a C, or whatever grade you have. So we have 9 to the 8 minus 5 equals 27 to the 5 minus 3. What's 8 minus 5? 3. So that's 9 cubed. What's 5 minus 3? 2. Equals 27 squared. So you actually need to figure out what those numbers are. So in the calculators, all of your groups should have one calculator. They probably fell on the floor, but there's one calculator. You're going to do 9 to the third power and figure out what that number is. And let me know when you guys have it. So what is 9 cubed? 729. So if the answer is actually 5, when you plug in 27 squared, it has to be 729. And it is. So then we could put a check mark. So if you get a number equals itself, like in this case 729, or 5 equals 5, or 100 equals 100, that means your answer is correct. If you get something like negative 2 equals 25, that means your answer is not correct, and you should go back and fix it. Okay, and I know not all of you are plugging in, but just so that you know, when you're using a scientific calculator, you should do 9. It looks like an arrow, but it's called a caret, and then 3. So I want you to learn that button. And the reason is, yes, you can do 9 times 9 times 9 without messing up. But if I gave you 2 to the 8th, if you miscount one of the 2's, like you only type in 7 or you accidentally type in 9, your answer is wrong now. So it's better to use the power and get the exact answer every single time. Okay, so example 1 will help you on the first 6 problems from last night's homework, or Friday night's homework. You had to rewrite the bases and then solve from there. All right, so then example 2, you have 4 to the power of x minus 1 equals 5. So in this case, there isn't a base that I can use, meaning there's no number that I can think of off the top of my head that I can figure out a power to and get both a 4 and a 5. So we learned this on Thursday and Friday. You have to take a log on both sides. Notice how I didn't write a small number, right? I didn't write the base. So what's the base if I don't write it? 10. And why would I want to use base 10? So what's the reason for why we use base 10? Because it's on the calculator. And it is base 10 because I didn't write it. But the more important reason is it's on the calculator. So once you do that, if I want to expand, where do I put my power? To the front. And you're going to put it in parentheses. So if you were here Friday, this is all we did on Friday. Was solving problems exactly like this. So how do I get rid of log 4? We divide it. So divide both sides by log 4. These ones cancel. We get x minus 1 equals log 5 divided by log 4. And then plus 1 on both sides. So x equals log 5 divided by log 4 plus 1. So yes, it looks nasty, but that just goes straight into the calculator. You do log 5, close your parentheses, divided by log 4, close parentheses, and I would hit enter. And here's why. If you want to do it all in one step, like type it all together, you're going to need about 3 sets of parentheses. And if you don't type them in, you're going to get the wrong answer. So it's better just to do multiple steps. Like you could even do log 5, enter, divide, log 4, enter, and then plus 1. And that way you get the right answer. So again, if you're not using parentheses, your calculator is going to read it differently. Because it's whatever this number is, then plus 1. So that's why you have to make sure that you're using enough parentheses. And if you're not, you're going to have all your work correct, and then your final answer is going to be wrong, and you're not going to get full credit because your final answer is wrong. You'll get partial for having the work, but you won't get full because of plugging in, and that would suck. Okay, so go ahead and put that in the calculator and tell me what do we get. So you get 2.16. Give me one more number. Well, it would be 0.9, so we're going to round that up to a 1. So it was 2.161. Okay, so if you look at this PowerPoint when I figure out how to post it, because Haiku hasn't liked me very much these past couple days, the way it will show is what I just did on the left-hand side, but there's another way to do it to get the same answer. So if you like doing the loop, meaning you're pretty good at converting, then this way might be easier. So I like doing the loop, and so that's typically how I solve my problems. This is exponential. So if you're doing a loop, you're converting it to a log, which means you have to write the word log. So what's the base of my log? 4. So it's log base 4 of 5 equals x minus 1. So we still don't know what the heck log base 4 of 5 is, because you have to guess. But that's why we learned the change of base formula on Friday and Thursday and like a week before that. So what base is on the calculator? 10. So you always want to change it to base 10. And we did this together on Friday. So I'm going to change this to log 5 divided by log 4. And notice now it looks identical to what I just did. This is second method.
Oh, so we don't have to do it like that?
No. So you're going to pick whichever method you like best. So, well, I think I told your class on Friday that it's base on bottom. So when you're changing the base, whatever this original number was has to be the thing that's being divided on the bottom. So it needs to be on the bottom. If it's on top, it's wrong. That's not how you change a base. So the small number needs to be on the bottom. Yep. 1. So now it looks the same. So then we would add 1, and I would get the same answer in 3 steps. That took me, what? I took a log, that's 1 step. Divided, that's 2 steps. Added 1. So it's just a shorter step, but you get the same answer. So you just pick whichever one you like. But either way, the answer is 2.161. So I'm more likely to use a loop and then change the base. just because it looks somewhat prettier to me. But if you like what I just did on the left, then do it that way. You're going to get the same answer regardless. Okay, so I'm not going to show you checking, because checking just means we plug in what for x? 2.161. So go ahead and plug that into your calculator. You're doing 4 to the power of 2.161 minus 1, and then see if you actually get 5. So plug in and check your answers. Third power is 8, and 2 to the fourth power is 16. But we don't want to guess. I want to know exactly what it is. So we're going to change it to base 10 because that's on the calculator. So again, when you change it, the big number's on top. So it's log 15 divided by log 2. So again, base on bottom equals 3x. So if you don't like how that looks because like the fraction is throwing you off, then you could actually do log 15 divided by log 2 and get that number and be done with the fraction. But I usually save it to the end only because you get less of a rounding error. But it doesn't really matter to me. So how do I get rid of that 3 that's next to x? Divide by 3. So everything is divided by 3. So that tells me x equals log 15 divided by log 2, and then whatever that number is, divided by 3. And you should get 1.302. Okay, so I'm done. You can work on your homework.